Hello friends, good morning. I'm Firoz from KV NTPC Farakka. Today we are going to discuss logarithmic differentiation. Before we go for the logarithm differentiation, we'll be discussing about what is a logarithm function. If a is a number greater than 0 not equal to 1, then the function defined by f of x is equal to log of x to the base a, where x is greater than 0 is called the logarithmic function. Now here we know this function is defined only for all x greater than 0, for all positive numbers. Secondly, that there are two types of logarithm. One is mainly we are using the natural logarithm with base e. What is e? E is a number, Euler's number, whose value is 2.718 dot dot dot, and y is equal to log of x to the base e is known as natural logarithm, which is invented by John Napier. So in calculus, normally we go with the natural logarithm, and you will find that if the base is not mentioned, so we will consider this as natural logarithm only. Few properties of the log function. Log of xy is log x plus log y. Log of x by y is log x minus log y, and log x to the power n is n log x, and log of e to the base e. Here always for all these we have taken the base, considering the base as e only. So log of e is equal to 1, and log of x to the base a, we can change the base. This is called base changing formula. We write it as log x by log a. We can change any base which we can do it as per the definition. So here we may use log of x by log of a to the base e. Now, what is chain rule? Because we will be applying chain rule when we take the logarithm. If g is differentiable, if g is a function differentiable at x and f is a function differentiable at g of x, then the composition of two functions h of x means f of g of x is differentiable at x. And how do we differentiate it? The derivative of this function is very simple way. First we take the derivative of the outer function. Outer function is f here. So the derivative of f, and then we take the derivative of the inner functions. So we'll be telling about outer function and inner function. For example, let y is equal to sine x square plus 5. We have two functions. One is the sine function and other is the polynomial function x square plus 5. Here the outer function is sine, inner function is x square plus 5. Now we want to find the derivative of this function. So first we'll find the derivative of sine. Derivative of sine, we know it is cos of the function, and then the derivative of x square plus 5. Derivative of x square is 2x and 5 is 0. So we can write this as 2x cos x square plus 5. Now this is about the chain rule. Now why do we require the logarithmic differentiation? Now consider, we will discuss this with the following examples. We have a question, y is equal to x cube, function to the power some constant. So we know how to find out the derivative. We can write dy by dx is 3x square. Now if you are having y is equal to 3 to the power x, now constant to the power variable, that also we know the derivative is dy by dx is 3 to the power x log of 3. Means we know that the derivative of derivative of a to the power x is a to the power x log a. Now if you are having a function y is equal to x to the power x, variable base and variable as power. Now we do not know how to differentiate this function. So we require here the logarithmic differentiation. So why it is required? So to differentiate functions of the form f of x to the power g of x means the base is also a function of variable x and the power is also a function of variable x. So here we'll be taking the logarithmic differentiation, and for easier differentiation of function which is a product of some more functions, there also it will facilitate, the logarithmic differentiation will facilitate our process of differentiation. Now how to find the derivative? What we do, if you are having a functions of the type u to the power v, means base is a function, differentiable function of x, and power is also a differentiable function of x. So what we do, we'll assume let y is equal to u to the power v, taking log on both the sides, log of y, log of u to the power v, and by applying the properties of the power like log m to the power n, we can write this as v log u. Now we'll be differentiating with respect to x. So derivative of log of y is 1 by y. Now since we are differentiating with respect to x, now we'll write derivative of y with respect to x means dy by dx, and taking the log on the both sides, it is differentiation on the both sides, d dx of v log u. Here we have been able to express the functions in the product form. So we'll apply the product rule. First function derivative of second, second function derivative of first. So dy by dx, take y this side and then write the whole thing and ultimately substitute the value of y. That gives you the derivative of this function. We'll see some examples here. Now differentiate with respect to x. First function is x to the power x, second function is x to the power x to the power x. Now let y is equal to x to the power x, taking log on the both the sides. So log of y is log x to the power x, can be written as x log x. Now differentiating with respect to x both sides, log derivative 1 by y and y dy by dx. Now here again we'll be applying the product rule. So the first function derivative of log of x is 1 by x, second function log x derivative of x is 1. Now we can write dy by dx as y, this gets cancelled, so 1 plus log x, and substitute the value of y, x to the power x, 1 plus log x. On the same line we'll go for the second one, taking log on the both the sides. So log of y is x to the power x. So this is the power, so we can write it in this form. Now differentiating on both sides again with respect to x, log y 1 by y dy by dx. Now again we'll be applying the product rule. So the first function derivative of log of x 1 by x, second function and the derivative of x to the power x, that we have already got it. So now x to the power x 1 by x log x, this derivative we have already found, so we are not going for that. So x to the power x 1 plus log x. Take x to the power x common. Now we are getting 1 by x plus 1 plus log x log x. Now take y this side and substitute the value. So it gives us the answer. Now we'll take some more example. Now if x to the power y is e to the power x minus y, prove that dy by dx is log x by 1 plus log x whole square. Now we have this, we are getting now taking logarithm on both the sides. So log of this x to the power y is log of e to the power x minus y. So we can take the power x minus y log e, and we know log e is equal to 1. So we are getting y log x is x minus y. X minus y. We can take y on one side because we want to find dy by dx. So y 1 plus log x is equal to x. So y, it is better to simplify and get y one side if it can easily be brought at one side. So y is equal to x by 1 plus log x. Now we'll differentiate, we'll apply the quotient rule. So v denominator, derivative of numerator x1, numerator derivative of denominator means 1 0 log x 1 by x and denominator ka square. So we'll simplify and it gives us the result. One more example we'll see, and very important to note here, differentiate, we have the function to the power function and it is in the summation form. There are two functions of that type. So now let y is equal to, again here we should not do a mistake of taking logarithm on both the sides, because meaning even despite our repeated telling, the students do this mistake. What they do, they write log of y as log of x to the power sin x plus log sin x to the power cos x. That will not do, because we don't have this formula. We do not have log a plus b is equal to log a plus log b. So this will never do. We should not do this mistake at any point of time. So what we are supposed to do, we take the first function as u, second function as v. So we are getting y is equal to u plus b. Now if you want to find out dy by dx, means differentiating with respect to x, so we should get du by dx and dv by dx. So u is equal to x to the power sin x, take log u, so sin x log x, again apply the product rule, sin x log x 1 by x, log x is cos x, here this side is 1 by u du by dx. Now du by dx, take u this side, sin x by x, cos x log x, substitute the value of u, so you are getting this. Again on the same line, v is equal to sin x to the power cos x, so log v is cos x log sin x. Now again differentiate both the sides, so derivative of log v 1 by v and v with respect to x is dv by dx. Now again we'll be applying the product rule, first function derivative of log of sine 1 by sine and derivative of sine. Now again this is here the composite function. First we have taken the derivative of log and then we are taking the derivative of sine. So log is 1 by sine and sine is cos. Again on the same line, second function derivative of cos is minus sin x. Take v this side, so we are getting cos by sine is cot x, cos x cot x minus sin x log sin x. Substitute the value of v, so we are getting sin x to the power cos x and this whole thing. Now if you want to find out dy by dx, you substitute the value of u and then v, that gives you the result. Here in this type of derivative, when you take the logarithm, it's very important to note that before you take the logarithm, you should understand that we are allowed to take the logarithm. Means the function, log function is only defined for the positive number. So if the number is negative, we should not be taking the logarithm. And so we have seen with these examples that how our derivative has been made very simpler. So this is how we use the logarithmic differentiation for finding the derivative of a complicated type of function, or where you have the function to the power as function and the functions in a product form. So what we do, we actually write that functions in the product form and then we apply the product rule. Thank you very much. We see you in the next video. Thank you.